Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to graph parabolas using the geometric definition, but when the vertex is not at the origin. So first thing I'm looking for is, do I have x squared, which means it's going to open up or down, or do I have y squared, which means it's going to open left or right? And here I've got x squared. So the format for these equations is going to be x minus h quantity squared equals 4p times y minus k. The vertex will be at hk. And then I can use the value of p to count in the direction that the parabola opens from the vertex. That's where my focus is. I'll move the same distance in the other direction. That's where the directrix is. So first, I've got this down to up or down because I've got x squared. So left or right is not part of the picture. Because the 8 is positive, that means that this one's going to open upward. So wherever my vertex is, when I find P, I'm going to move up that number of units to get the focus, and I'm going to move down that number of units to get the directrix. So it's really similar to what we just did. We just start with a different point. So here, I know that h is 3 because that's what's being subtracted from x. And I know that k is negative 2 because that is really the same as y minus negative 2. So my vertex is at 3, negative 2. And I know that this opens up, so when I find p from that point, I'm going to count up p units. I know that 4p is equal to that number in front of the y expression. So 4p in this problem equals 8, p equals 2. So that means that I can count up 2 units, 1, 2. That's where my focus is. And I can count 2 units in the other direction. That is where my directrix will be. Now, remember that where the focus is, if I move 2p to the left and the right, I'll find 2 more points that belong on this graph. P is 2. That means that 2 times p is 4. And so I can move 4 to the right of the focus and 4 to the left. Now I've got a good start for graphing this. What else could I do? I happen to luck into the x-intercepts here. I could find the y-intercept by putting in 0 for x. If you work that out, it's a little less than negative 1. I could also plug in negative 1 for y and solve for x. It's about 5.8 and about 0.2. Anyway, you can get more points and more precise, but this is just a rough sketch here, so that should do it for that one. Let's take a look at one that's going to open to the left or the right instead. So I've got y squared. That tells me that it's either left or right. 4p is negative. It equals negative 12 in this case. That tells me that it's going to open to the left in the negative direction for a horizontal parabola. H equals 1 because that's what's being subtracted from x. K equals 4, that's what's being subtracted from y. So the vertex is at 1, 4. 1, 4. 4p is equal to negative 12. P is equal to negative 3. Now we're moving, this one's opening in the left direction, so negative 3 tells me to go 3 to the left to get the focus. It's going to be about there. 3 to the right gives me the directrix at x equals 4. The distance for 2p, that's going to be 6, so I go 6 above and 6 below. Now I've got a couple more points that I know this passes through. I could find the y-intercept by putting in 0 for x, solving for y, etc. But I know that the graph is going to look something like this. And again, we can get more precise by trying to find where are the y-intercepts, what is the x-intercept, etc. All right, that's it for graphing parabolas using the geometric definition, the focus, and the directrix when the vertex is at a point other than the origin. In the next couple of videos, we're going to be working backwards. We're going to be trying to find the equation of a parabola if we know something about its graph.